Hi, Dave Kabilka here. The purpose of this video is to talk a little bit about the plate tectonics assignment and specifically about the maps that you're going to need to reference in this assignment, for which there are three. One's called the NGDC color bathymetry map. One is called the seismology map. And the third one is called the volcanology map. Let's take a look at each one of these individually. First, the NGDC color bathymetry. It's at this link right here. I already have it open, so if I click on this link, it'll bring us to a website that looks like, there we go, that looks like this. One thing you need to do with these maps is to right away figure out what these maps are telling us. So this is a color bathymetry map. In other words, the color gives us an indication of the height of the land above sea level or the depth of the ocean water. So if it's the depth of the ocean water, it tells us something about the lay of the seafloor, the topography of the seafloor. Well, the word for seafloor topography is bathymetry, or water depth. The two mean the same thing. And the color code works like this. It's over here on the left side. Here's sea level right there. That's 0 line. So any land surface that's above sea level is colored green, orange, yellow, red, colors like that. So green is really low land surface. It's the yellows, oranges, and reds that tell us that the height above sea level is getting pretty high, like mountain ranges and stuff like that. And then water depths are in blue. Shallow water is light blue, deep water is dark blue, and then purples and stuff are the deepest parts of the ocean. So I can click on any one of these squares and we can see what the area looks like, the bathymetry or the topography looks like. So I can click on it, biggie size that square. I can click on it again and biggie size. If I click on it a third time, it really zooms us in. So this is an area in South America that has all depths and heights. So here's fairly deep ocean water, and we don't have to worry about the number, of meters below sea level, but rather what the lay of the ocean floor, of the land surface looks like. So here's what we can interpret from this. If I run a line from here to over here, and I describe how Earth's surface changes along this line, it might look like this, where the seafloor is kind of flat, and then we get a really dark blue color, which is telling us that there's like a really area of really deep water there, like a trench, it looks like, a ditch or a trench. And then it rises up. The shoreline is right about there. That would be sea level. And then it rises up to a tall chain of mountains on the land surface that's adjacent to this deep ocean trench. So there's two characteristics that often run together on the surface of the earth, and that is a deep ocean trench and a chain of mountains right along the coastline. And these mountains happen to be volcanic. It doesn't say volcanic here, but I can conclude that because I already know a little bit about this area. Okay, that's one map. Another map, that's the NGDC color bathymetry map. Let's take a look at the volcanology map. So let's see here. If I click on this link right here, it brings us to the volcanology map. Now, how do I know this is a map of volcanoes? Well, I read the description over here. In the lower left side of this map, it says volcanology. It says red. Let me zoom in some more so you can see this. It says red dots sideways, but red dots indicate currently or historically active volcanoes. So all the red dots are volcanoes. Looking at this map, we can get a feel for where the volcanoes are on the surface of the earth. And you can see there's a definite pattern to this. They're not randomly distributed all over the place. There's chains of volcanoes. In fact, the area in South America we were just looking at, a chain of active volcanoes all the way up the spine of western North America, chains of volcanoes, the Aleutian Islands. And then out in here in other places, nothing. So there's a pattern to volcanoes. Let's take a look at the one more map here. The one we haven't looked at yet is a seismology map. So if I click on this link right here, this will bring us to the seismology map, which is right there. So this one's a little bit different because it's got a lot of dots, but they're also different color dots. So what do those mean? Again, if I zoom to the lower left side of the map, there we go. Zoom in a little more so we can really read this thing. It says earthquake locations 1990 to 1996. So 6 years of data. Magnitudes 4 and greater. So fairly strong earthquakes. It says color indicates depth. Red, so how deep below the surface of the earth the earthquake occurred. It says red 0 to 33 kilometers. Orange 33 to 70, green, it's got a number, and then blue 700 to 300 kilometers below the surface of the earth. So red, here's what you need to remember. Red are shallow earthquakes. Blue are really deep earthquakes, and then the orange and the greens are kind of intermediate depth earthquakes. That's kind of how this plays out. So again, if I back off, now we can see the pattern of earthquakes on the surface of the earth. And just like volcanoes, they're not random, are they? There's places where there's lots and lots of earthquakes, very dangerous places to live. Oh look, San Andreas Fault. And then there's other places like Minnesota where there's almost never an earthquake, and they're pretty seismically safe places to live. We don't have earthquakes here, we don't have volcanoes here, that kind of thing. So again, you need to know and acknowledge what these maps are showing you, and then compare all three, and you start to see patterns, which we will talk about next. So I will see you on the computer.